So hi guys, in this video I want to acquaint you with the idea of a pointer. So the idea of a pointer is not too difficult to understand. Every byte in a computer's memory has an address. If you have a megabyte of memory, you know that a megabyte is approximately 1,000 kilobytes and a kilobyte is approximately 1,000 bytes. If you have a megabyte of memory, you have approximately 1,000,000 bytes, and the address ranges from 0 to 999,999. A pointer is basically a variable which stores one of these memory locations. That is, it stores one of these values, one of these numbers from 0 to 999,999. If a variable I, let's say, is present in memory location 1000, then we say that the pointer to I is a variable that stores the value 1000. Okay, so I think that made the idea of a pointer pretty clear. So next, let's discuss static and dynamic allocation of memory. So the difference between static and dynamic allocation of memory is pretty clear. For certain variables, the program calculates how much memory space is required when it compiles, and it reserves some memory to use every time it's run. This is static memory allocation. That is, before you run the program already knows how much memory it needs to reserve, how much memory is required at max basically. Dynamic allocation is essentially allocation during runtime. The compiler does not account for this or reserve space for this. Memory is allocated during runtime. This is usually done when we don't know ourselves what kind of memory is required beforehand. For example, let's say we want to we ask a user how many things they want to store, and let's say they say 3 elements. So we dynamically declare 3 elements, but if they say 4, we have to dynamically allocate 4. So basically we do it during runtime based on what the user tells us to do. That's dynamic allocation. But when we have talk about dynamic allocation, it doesn't always have to be done like when we don't know how much space we need to allocate. Like the operations that are associated with dynamic allocation actually allow us to manually control when the object is created and manually control when we want to delete the object, when it goes out of scope. So even in a scenario when we know how much memory we need, we sometimes use dynamic allocation when we want to control the scope of the variable. So basically, if we want greater control over memory allocation, when we want to tell the compiler we got this, don't do anything, we allocate dynamically. So I hope that made it clear. See you next time. Thank you.